Hello, welcome to Pre-Cal Lecture 1.9b, where we continue our discussion of factoring patterns. Section 1.9.3 is where we're going to learn to factor the sum and difference of two perfect cubes. All right, so the first formula to memorize, so if I have an asterisk by it, then you need to make sure to memorize it, is a cubed minus b cubed. So that factors into a minus b times the quantity a squared plus ab plus b squared. So the way I remember it is the minus sign goes in the very first parenthesis, and in the second parenthesis it's all plus. Okay, so let's expand this back out just to check. So we have a times a squared is a cubed. Then a times ab would be plus a squared b. And then a times b squared would be plus ab squared. Then we have negative b times a squared would be minus a squared b. Then negative b times ab would be minus ab squared. And then negative b times b squared would be minus b cubed. So a lot of this cancels out. Positive a squared b, negative a squared b, those cancel out. ab squared, negative ab squared cancels out. And all you're left with is a cubed minus b cubed. So you can see that that is the original and it checks. So this works out. The next formula you have to memorize is if you have a sum of two perfect cubes. So a cubed plus b cubed. Well, that's going to factor into a plus b, so the plus sign matches the front parenthesis. And then it's just the same as this, except we have a minus sign right there. So we'd have a squared minus ab plus b squared. So you need to memorize that formula as well. We'll go ahead and expand to check to make sure I don't have a mistake here, but this is just for this lecture. You don't ever have to do this again. So a times a squared would be a cubed, and then a times negative ab would be minus a squared b, and then a times b squared would be plus ab squared, and then b times a squared would be minus b times a squared would be plus a squared b. B times negative ab would be minus ab squared. And then b times b squared would be plus b cubed. And all these middle terms cancel. Negative a squared b, positive a squared b, positive ab squared, negative ab squared, and you're left with a cubed plus b cubed. Okay, so let's use these formulas with some examples here. So our first example is factor 8 minus t cubed. All right, well, is 8 a perfect cube? Well, yes, it is. 2 times 2 times 2 would give you 8. So a is 2. How about t cubed? Well, the cube root of t cubed is just going to be t. Right? So b is t. We know it's a minus, so we're going to use this first formula. So this would factor into 2 minus t, right? That's a minus b times a squared. 2 squared is 4. And then all of the signs are plus in the second quantity. So plus a times b, that would be 2 times t. And then plus, we have b squared, right, in the formula. So that's going to be t squared. Okay, so that's the answer. Could you check this? Yes, you could. And if you have time on your test, I would. expand it back out just like we did before, and do you get to 8 minus t cubed? If you do, then you know you got it right. All right, let's try another one. All right, we want to factor 125a cubed plus 27b cubed. Okay, what is a? Well, the cube root of 125 is 5. Now let's say you're not sure about that. You can just put it in your calculator. Take, clear, 125, raise that to the 1/3 power, and your calculator will tell you that it's 5. All right, so b, and of course it would be 5a here because the cube root of a is a. If you cube this back, just to check, if we did this, 5a cubed, 5 is cubed, so that's 125. A is cubed, that'd be a cubed. So that's what we're talking about. B, what's the cube root of 27? It's 3. So B is 3b. Just to make sure, if you want to cube that, it would be 27b cubed. All right, so our factor, we're plus here, so our first quantity would be a plus b. So 5a plus 3b. And then our second quantity would have a minus sign, so we have a squared. Well, 5a squared is going to be 25a squared. And then we have a minus sign. A times b, 5a times 3b would be 15ab. And then finally plus b squared, right? We're right here, b squared, that's 3b all squared. All right, just show you my thought process here. 3 squared is 9, and then b squared would be b squared. So plus 9b squared. All right, so how could you check that? You would just FOIL it or multiply it back out, distribute the 5a and the 3b across, and you'll come back to the original 125a cubed plus 27b cubed. All right, so 5a plus 3b times 25a squared minus 15ab plus 9b squared. So pretty cool. All right, let's do one more of these. So fast forward through this if you want. I will just erase this bottom part so our formulas are handy. All right, and then our last example in 1.9.3, we want to factor. So kind of like in the previous lecture, we're going to go a little fancy here. 2x plus 3y all cubed minus 343. So this is actually the difference of two perfect cubes. What is the cube root of 2x plus 3y all cubed? Well, the cube root and the cube cancel, so you just get 2x plus 3y. So a is equal to 2x plus 3y. Now, you don't have to show me that. This is for illustrative purposes. And then b, you might not be sure about it, but 343 is actually a perfect cube. You can take 343 in your calculator, raise that to the 1/3 power, and you will get 7. So now we're just going to use the formula, the first formula, a minus b. So that's going to be 2x plus 3y minus 7. So I'm going to use brackets since I've got parentheses and everything here, times a squared plus ab plus b squared. Well, a squared would be 2x plus 3y all squared. All right, and then we have plus, because we're in this first formula, a times b, so that's going to be 7. We want to put the coefficient first, times 2x plus 3y. And then plus b squared, 7 squared would be 49. All right, so that's really fancy looking, but it's pretty cool that we can use factoring patterns to factor that. You could check it. It would be quite a long check to distribute all that, but you could absolutely do that, and you would end up back here at the beginning. All right, let me erase all this, and we'll go to section 1.9.4. Again, I don't erase with a ton of vigor because my camera is up on a music stand, and if I'm not careful, it'll shake the camera pretty bad, mess up the focus. All right, 1.9.4. What we're going to do is combine everything that we've learned together. So we're going to do a factoring review. And we'll call this combining techniques. So we're going to use more than one technique in each problem. So let's put out up top, we're going to do some of our formulas. So first of all, the difference of two perfect squares. Let's say it's a squared minus b squared. Remember that factors into a plus b times a minus b, so that might be useful. And then the formulas that we just learned, a cubed minus b cubed. That's going to be a minus b times a squared plus ab plus b squared. So you just got to memorize these. And then a cubed plus b cubed. That's going to be a plus b. And it's almost the same as the previous one. We've just got a minus sign in between the first two terms here in the second parenthesis. All right, and then we're also going to maybe do some grouping. Just some regular factoring trinomials. All right, we'll use those techniques as well. Okay, so maybe some factoring out the greatest common factor, the GCF. All right, so our first example, we want to factor y times x cubed minus y times x to the sixth. So before you do anything else, we always want to factor out the greatest common factor. Well, what's the greatest common factor? It would be y times x cubed. Well, what's left? Well, y times x cubed divided by y times x cubed would just be 1. And then yx to the 6th divided by yx cubed, the y's would cancel out, and you'd have minus x cubed. So you've gotten some partial credit here. You factored it somewhat, but now we need to realize that 1 is a perfect cube. 1 times 1 times 1 is just 1, so it's a perfect cube. So this is the difference of perfect cubes. Okay, so in this case, A is going to be 1 and B would be x. So that yx cubed doesn't go anywhere. It's right there. And then we would have 1 minus x. So we're using this second formula here, right? A cubed minus b cubed. You do have to realize that 1 is a perfect cube, 1 minus x, and then times a squared, right? 1 squared is 1, plus a times b, 1 times x is x, plus b squared. B is x, so b squared would be x squared. All right, pretty cool. So that is factoring completely. So we didn't just factor out, so we want to put completely down here. We didn't just factor out the greatest common factor. We took it as far as we possibly could. All right, let's do another example. I've got room on the board here. let's say we want to factor x to the fifth minus 2x to the fourth plus x cubed. So do we have a greatest common factor there that we could factor out? Well, yeah. We could factor out x cubed. And what would be left would be x squared minus 2x, and then x cubed over x cubed would be plus 1. You might be tempted to stop there, but we can. This is a trinomial. All right, so we might be able to factor that. Okay, in fact, this would be a perfect square trinomial where you could, we have our first term as a perfect square and our second term, 1, is also a perfect square. But I can probably just factor this by eyeballing, and I don't really need to use the perfect square formula. So we'd have an x and an x, because that's the only thing that'll give you x squared, and the only thing that'll give you 1 is a 1 and a 1. And I just need to know what sign to put in between. Well, it's going to be a minus on both of them. Okay, so if we FOIL that back out, it's going to be x squared minus x would give us minus 2x. Then negative 1 times negative 1 would give me positive 1. I'm fine if you leave it like that, but I would be most impressed if you then wrote it like this: x cubed times x minus 1 all squared. That would really make me feel proud, but I'm not going to count off if you left it like this. All right, well, I've got 3 more examples for you that are even fancier. Okay, so let's factor 2x to the sixth minus 2x to the fourth plus 5x to the fifth minus 5x cubed. Now we could go ahead and factor out the greatest common factor to start with, or because it's 4 terms, you might want to just go ahead and factor by grouping, and then we'll factor out the greatest common factor next. Doesn't really matter to me. When you see 4 terms, just think grouping. So here we would have a 2x to the fourth is our greatest common factor, and here we're 5x cubed would be our greatest common factor. So 2x to the fourth, what's left here would just be x squared minus 1. All right, and then here we would have, I'm going to hold off on the sign, 5x cubed, and that's going to be x squared minus 1 again. So I do believe we need a plus sign in between the two to make it get back to this in terms of our sign. So what we have would be 2x to the fourth plus 5x cubed. So I'm adding these two together, putting it in a parenthesis, and then x squared minus 1. So we actually have quite a bit more we can do here. First of all, we can factor out the greatest common factor of these two. That's going to be x cubed. So that would leave 2x plus 5. So we can't factor that anymore, 2x plus 5. But this is actually the difference of 2 perfect squares. So you do, in order to factor completely, we've got to recognize that a is x and b is 1. And it's a minus sign, so difference. So what is our formula for that? Well, it's a plus b times a minus b. So that's going to be x plus 1 times x minus 1. All right, so that last part can get you if you forget to notice that that's the difference of 2 perfect squares. All right, so outstanding. That's pretty cool. All right, I think I can fit the next one here. It's a unique one. let's factor x to the 27th plus y to the 33rd. Now, something you see like this, this is actually two perfect cubes. We just have to rewrite it. So anytime you see these exponents, both exponents are a multiple of 3, we can rewrite it like this: x to the 9th to the 3rd. Right? 9 times 3 is 27. Now that's a perfect cube, plus y to the 11th to the 3rd. 11 times 3 is 33. So that's a perfect cube. Okay, so A, in this case, would be x to the 9th, and B is y to the 11th. So we're going to use this addition or sum of two perfect cubes formula here. So we would have A plus B, that's x to the 9th, plus y to the 11th, times A squared. Well, what's x to the 9th squared? Well, it's x to the 18th. And then it's a minus sign, right? We've got a minus sign here. A times B, that's just going to be x to the 9th times y to the 11th. And then finally plus y to the 11th squared, b squared. So that's going to be y to the 22nd. So this looks terrible, but it's actually pretty easy. So that's how it factors. You just got to recognize if both exponents are a multiple of 3, then you can write them differently as cubes. All right, cool. So to me, factoring patterns are pretty fun. It saves a lot of time. Some of these things without these patterns would just be, to me, kind of impossible to factor. All right, let's do one more. Good practice for the homework. So we want to factor, again, completely. For x to the 6th. So that's always going to be the case. Factor completely. For minus 16x to the 4th. Plus 3x to the 5th. Minus 12x cubed. So here, what I want you to do, pause the video. This is kind of like one we previously did, and give this one a try. So go ahead and pause it and give it a try. Okay, so this is what I would do on this. First of all, it's grouping. It's 4. So let's do the grouping first. So we could factor out 4x to the 4th for these first two, and 3x cubed for the second two. So if we factor out 4x to the 4th, what's left? X squared minus 16 over 4 is 4. And x to the 4th over x to the 4th, it goes away. All right, here we've got 3x cubed, and it should be the same thing, right? X squared minus 4. And I'm going to need a plus in between. So let's put all this together. We've got 4x to the 4th plus 3x cubed. Now, if this was a minus sign here, it would be minus 3x cubed times x squared minus 4. Okay, we can factor out some more x's here, right? So we could put an x cubed out front. Then what's left would be 4x plus 3. But here, this is again the difference of two perfect squares, where a is x and b is 2. So that factors into x plus 2 times x minus 2. All right, really cool that we can factor that with those multiple techniques. So your homework is to finish worksheet 1.9. So that's going to be 11 through 18. and you will get to use the techniques that we learned in today's lecture. All right. Well, I hope that lecture made sense, and I'll talk to you on the next one.